the storage problem is finally over. But how did I solve it? In the last video I explained why I had to redesign the entire project just to add an external flash memory. And in this video I'll explain why the storage is no longer a problem. And so let's start the video. For this project I'm going to use two different file systems. The first one will be LittleFS system for the internal flash, and then I'm going to use FAT file system for the external flash. LittleFS system is used on the 2 MB internal flash, and here I will store all the audio files that guides the study session itself. Then FAT file system is used on the 16 MB external flash, and here I will download every flashcard audio files for the study session. This setup allows me to erase only the external flash directory without touching the internal flash for every study session. This configuration is actually very easy to replicate. It's no more complicated than using LittleFS system or SPI file system on the internal flash. But there are a couple of details you should pay attention to. The first thing is the partition label. In many online examples, this label is often something generic like storage. That works fine at first, but if you plan to host multiple partitions in the future, you should definitely give each one a unique label. As you can see from my code, in the LittleFS configuration, we have the partition label named as storage. And when I decided to add also the external flash, I had to change this partition label for the external flash to avoid problems between the two partitions. Other than that, everything is pretty straightforward. Once both file systems are mounted correctly, you can use the same POSIX functions with both LittleFS system and FAT file system. The only thing that changes between the two is the directory. For example, here on GitHub, I will show you two functions of my code that will basically clean the directory for the external flash and for the internal flash. The only thing that changes between the two is the directory. Here we got the external files, and instead in the internal files I'm going to use the LittleFS directory. Before moving on with the video, I would like to also show you two things that might be new for you. The first one is the partition CSV. As you can see, you have to provide a CSV file if you would like to use LittleFS on your ESP32 project. Remember to enable your partition CSV by going into the menu config on partition table and custom partition CSV file. The second issue that might be new for you is the LFN, that stands for long file names for the FAT file system. While I was developing, FAT file system was mounting correctly on my ASP, but it was failing every time the HTTP downloading of the files. Then I found out that the problem was actually the name of the file. Since I'm using the card ID from Anki for my files, this was causing the issue with FAT file system. And so to fix these problems, you have to open the menu config, you have to change this setting right here. You can find this setting on component config, then you have to go to FAT file system support and you have to enable the long file name either in IRP or in the stack. Now let's see how the entire storage system works. Everything starts from here, Anki, specifically from the first deck. In today's demo we are going to use these two cards. With this Python script right here, we can get the two cards that you have seen before, and we can create two audio files based on the front and the back of the card. We can get the cards by using the REST API of Anki. And if you want to know more about this, check out the old video of this series where I explain the Anki API. So as you can see, these two are the cards that we're going to try. We know that the server is on, and now if we want we can turn on the ASP and it will download the cards. Before doing that, if we are going to audio files, now we can see all the audio files created for the two cards. Basically every card has 4 files, because this script right here will create firstly the MP3 file, and then it will convert the MP3 file with the WAV file that can be used by our speaker. And now we're going to turn on the ASP and we're going to see how these files will be managed with the monitor of ESP32. I forgot to comment some lines of code, and now I will show you how I also upload files into the LittleFS directory. So as you can see, we have deleted all the files into the LittleFS directory, and so we have to re-download them again. So the only thing that it's missing, the actual files. We're going to take this, that, as I said before, are useful for every study session, and so they are not supposed to be deleted. Right here are the files that we're going to study, and we're going to also add the utility audio files. And now let's reboot the ESP.
Let's begin your flashcards. Press blue to download or yellow to start.
So as you can see, there is also the watchdog problem, but as I said in the last video, we're going to fix it and it's not causing problem with the demo. We have downloaded all the files that I've shown you before.
All audio files have been deleted. Downloading audio files. All audio files have been downloaded. Anerkennen, erkennt an, erkannte an, hat anerkannt.
Now I'm going to finish this study session.
To recognize.
For the next study session, we're going to erase the old study sessions cards and we're going to download the new cards. And now let's finish this demo by looking at Anki software. Now we don't have any due cards for today, and we can see that we had studied 2 cards in 0 seconds today. Thank you guys for watching. If you have come this far, in the next videos I would like to upgrade the audio output to this project, and so this will be the topic for the next improvements. And then I'll be moving on with the PCB, and we're going to see in the next one.